Welcome to our next lesson, where we'll spend most of our time talking about factor trees. Okay, so we're up to week 3 there, like it says on the screen, factor trees, which is exercise 2.3. Okay, a little bit of background. Prime numbers and composite numbers. So a prime number is a counting number. It has exactly 2 factors, which is itself and 1. By counting numbers, we mean like whole numbers, so not fractions or decimals or anything like that, whole numbers. And there are only 2 factors, itself and 1. We looked at a bit of that last lesson. So number 3 is a prime number because its only factors are 3 and 1. So you can only go 3 times 1 to make 3. There's no other way of doing it. 2 is the only even prime number. His only factors are 2 and 1. He's a bit of a special one. A composite number is a bit different because he's got more than 2 numbers. So here's number 4. Here's an easy example. It says here its factors are 1, 2 and 4 because we can say 1 times 4 equals 4 and 2 times 2 equals 4. So we've only ever, in that scenario, we only use the numbers 1, 4 and 2, which is why we said there. 1's a special number because he's not really prime or composite. It's just a little bit different. And we can make up nice little tables like these ones down here, where the prime numbers are highlighted and the composite numbers are highlighted. That's the numbers from 1 to 100. Obviously, you can see that there are a lot more composite numbers than there are prime numbers. There's a few prime numbers here in this first row on the numbers up to 10. But then it starts to thin out as you go up. Okay, so moving on to factor trees. So every composite number can be written as a product of the powers of prime numbers. What does that mean? So 12 we can make up from 2 times 2 times 3. Now 2 times 2 is 2 squared times the 3, which is that there. All right. It's just a way of putting together numbers that you multiply together to make that number that you're looking for. A factor tree shows the prime factors of a composite number. What does that mean? Basically, we start off with a number, like in this scenario here, we've got 48. Now, we think what 2 numbers can multiply together to equal 48? We know that it's 8 times 6 equals 48. All right, 6 8s are 48. And then we look at each of those numbers in turn. 8 can be made up from 4 times 2, and the 4 can be made up from 2 times 2. Then we come back and look at the 6, and he's made up from 3 times 2. His factors are 3 and 2. And that's what I meant when I was saying this little sentence over here. It's just a matter of starting with your initial number. All right. You draw a line out each side, write down 2 factors, and then you just keep breaking them down until you end up with prime numbers. 2 is a prime number and 3 is a prime number. So we've got 2, 2, 2, another 2 there. So we've got 4 2s, which is listed there, and we've got a 3, which is listed there. And they're all multiplied together. So if you got your calculator and you did 2 times 2 times 2 times 2 times 3, you will end up with 48. All right. We could alter this, and if you remember from our previous lessons, 2 times 2 times 2 times 2 can be written in index notation. That's 2 is the base, there's 4 of them, so 4 is the index, so it's 2 to the power of 4 times 3. And that's another way we can write the number 48. If we look down here at our other example, 92, he's a little bit different. He's got less factors, so we can make it up from 2 times 46. All right. And if you're not sure with these, 92 is an even number, so you know it's going to be divisible by 2. You can halve it. All right. 46 again is an even number, 2 times 23. So we can make up 92 from 2 times 2 times 23, or we could say 2 squared times 23. Same thing. All right. Now this process that we've gone through where we do these lines and all these levels of multiplication down, like we've done up here, that's what we refer to as a factor tree. We end up with prime numbers at the bottom here, so we're making up the number that we're starting with from its prime factors. That was this line that I did here, and then I changed it when I did this line here and wrote it in index notation, and that's the only variation. That's all you're doing in these activities. So let's have a look at this one. Find the prime factors of 50 by drawing a factor tree. Here's what we do. We start with 50, we draw our two lines. Now 50 ends in a 0, so you know it's divisible by 10, 5 times 10, and that's this line that we've written here. Once you've done that, 5 is a prime number, so you can't go any further. All right, and if you're not sure, you can scroll back to the second slide, I think it was, where we had those two little tables down the bottom right corner where we listed prime and composite numbers. 10, once again, he ends in 0, so you know he can be made up from other numbers. 10's an easy one, it's also even, so you can halve it. 5 times 2 makes up 10, and we write that like this down here. This diagram that we've done here is our completed factor tree because we've ended up with prime numbers. And then all you do to finish off is write a nice little statement. The prime factors of 50 are 2 and 5. Okay, because we've got 5s and we've got 2s. The only variation of that is if you want to write it as slightly differently. 50 equals 5 times 2. Or you can write the 5 times 5 as 5 squared times 2. Same thing. That's the only variation on it. And that's all you're doing in these activities. Let's have a look at this one. 60 on the left hand side here, we could make that up from 6 times 10. 6 is made up of 2 times 3. 10 is made up of 2 times 5. So our prime factors are 2, 3, 2, and 5. We don't really need to rewrite in that second 2 in there, okay? But there's our prime factors there. All right. And this bit down here is just doing that last little bit that I did where we start to write it in index notation, 5 squared times 2. All right. All these questions from here on are basically based on just exactly what I've done there. It's done exactly the same way. So you can work through all these in your own time. And there's plenty of examples to have a go at. Okay, so let's sum up what we've done. Remember, a prime number is a whole number, which is exactly 2 factors, itself and 1. A composite number has more than 2 factors. You can see on the right hand side here that 20's got more than 2 factors, so it must be a composite number. 1 doesn't really play the game because it kind of doesn't really work that way, neither really prime nor composite. A factor tree is how we work out the prime factors of a composite number. The last numbers that we end up in a factor tree are all prime numbers, so that's why we're calling it the prime factors. 2 is a prime number, 2 is a prime number, 5 is a prime number, so we found the prime factors of 20. Every composite number can be written as a product of prime factors. That means, product means times, so you can multiply its prime factors together to get the number. 2 times 2 times 5, which is what we've written there. The product of prime factors, so multiplying prime factors is what that means, can be written shorter using index notation. 20 equals 2 squared times 5. 2 squared because there's 2 2's. 2 is my base, there's 2 of them, so 2 is my index. Lowest common multiples and highest common factors can be determined by expressing numbers as products of their prime factors. It's another way of finding that the lowest common multiple or the highest common factor. It's just an alternate way of doing it. Remember, they become useful in fractions and things like that. All right, so where do you go from here? Have a go at exercise 2.3, do those exercises listed in that middle section there. Thanks for coming.